Well, we kind of slowed down on who's coming in. Randy, did you want to talk shop for a minute?
Sure. Hi, everybody. Welcome to our November meeting. It's a pleasure to have you all here. Just a couple quick announcements. I wanted to welcome a couple new members, Miriam Kalsa, who has been, as he said, I think lurking in the wings for a while and bit the bullet and decided to join, so welcome. If you're here, I can't see everybody that's here, so are you here, Miriam?
Doesn't look like.
Okay. I just thought maybe we could have him say a couple words. And we have a new member today, Elaine Rees, R-E-E-S. I think I'm saying that right. And just a couple of quick announcements. We're still accepting dues from new members anytime and old members anytime too. Although the dues were actually due on the 1st of October, we get dues all the way through April time. So, or even later, right, Jerry? So no problem there. I just wanted to also let people know, if you are a returning member, even if you've been a member 2 or 3 years ago and you're paying dues, it's $25 for you. That's not prorated for you. That's prorated fees are only for new members. So I just want to make that clear. And also, if you are a returning member, it's not necessary to fill out a new member application. If you have any updates, you can either call me and leave a message if I don't answer, or just send me an email if you have an address change or a phone number change or anything like that. With that, I'm done.
Okay. So we've got Rob Brown tonight. I'm gonna let Jerry introduce him, but I just wanted to say tonight, we're just gonna cruise through the whole thing. If you have a question, then you can type it in the chat. And then when we get to the end of the presentation, then I'll read out the questions from chat. And then if still haven't had something answered that you want to know, then we'll just open it up and y'all can just shout it out and be happy. So Jerry, take it away.
Okay, I will make one more announcement just for the people that came in recently. It looks like we are going to meet live at the planetarium next month. So, we haven't gotten the confirmation from every board member yet, but the ones who have responded have said, yeah, let's do it. So there'll be an announcement on the email list confirming that if we do, in fact, all vote unanimously to do it. I think probably even one negative vote would scotch that. So it's going to have to be unanimous, but I think it will be. So anyway, that's that. Does anybody have anything to show or tell or anything before we get into the program tonight? Okay, from that silence, I will assume that no one does. So let me tell you a little bit about our speaker tonight, Rob Brown. I've known Rob for at least a decade, maybe longer, from meeting at the Oregon Star Party. And those of you who go regularly to the OSP probably know about the scraggly tree on the, what would it be, on the west road out of the Star Party. We call it Rob's tree because Rob took a really iconic photograph of that tree on the very first time it was there, right?
Well, yeah, but it's not called that anymore.
Well, it's Rob's stump now because the tree was cut down. But the tree became the icon of the Oregon Star Party. It was on their T-shirt for a while. And anyway, this is the Rob of Rob's tree. So there's that little connection. Rob was one of the first people to experiment with making telescope mirrors out of ceramic. He and Mark Yonker worked on that, oh gosh, a decade or more ago. I don't know, do you guys work together or separately on that?
Separately.
Separately, okay, so it was an idea whose time had come, and both of them worked on it. Both had very iffy results, but it was a neat experiment, and Mark actually got a telescope made out of it, and I wrote about that a few months ago in my column in Sky and Telescope. But Rob was in on the ground floor of that movement too. And he's in on the ground floor of a new movement, which is silvering mirrors, which is sort of a going full circle back to the technology of a century or more ago, when silvering was the way we coated telescope mirrors. We didn't know about vacuum coated aluminized mirrors. Mirrors used to be coated chemically with silver. And this is something that's starting to happen again for various reasons. One, due to the cost of aluminizing. Another one due to the very low cost of silvering, which lets you go ahead and experimentally silver a mirror while you're still working on it. Rob will probably have a lot more to say about that as he tells us about the whole concept and the process of putting silver on glass. So with that, I'm going to turn it over to Rob. Take it away, Rob.
Okay, thank you. First of all, I see that Frank Sapansky has entered the waiting room. And can you let him in, please? or do I need to do that? Because I've got him on my screen.
He's been trying to get in and he keeps attempting to join and it's not working. So I had to send the link to someone else via email real quick that was struggling to get to.
If I click admit, is that going to work or am I going to screw it up? Okay.
No, don't worry about it. I got it.
Okay, I won't worry about it. All right. It's just showing right over your face.
That's not always a bad thing.
Yeah, golly. Okay, well, let's get this show started. Thank you for the introduction, Jerry. It's truly an honor to be presenting to this group. I know quite a few of the people that are in the room here, and it's always a pleasure to be able to talk in front of this crowd. So I will get started here by sharing my screen, and we will get going. Okay, slideshow mode, there we go. All right, so silver coatings for telescope mirrors, a technology revival. Maybe there should be a question mark on that, but with credit to Howard Banich, Bob Schock, Jerry Mertz, and Peter Pekurar for significant contributions, not the least of which is this 28-inch mirror that Howard has silvered, and we'll get going here. So in this presentation, I'm going to be talking about a brief history of silver coatings, reasons for a revival, materials procurement, application technique, testing, test results, and real world results. Now, this is a very high level overview. It is not going to go into a lot of gory detail with maybe one or two exceptions, but I want to keep this as high level as possible. And you'll see that I've put in here links, and they're all throughout this presentation. Hopefully they work in the PDF form that I've shared with Amy, but you can access far more in-depth information by going to several of the links that I have throughout here. A little bit more about me, and luckily enough, Jerry didn't touch on it. My career has been in engineering as an optical engineer, and that's no accident that I'm an optical engineer and into astronomy. So I work currently at Collins Aerospace. I've been there for over 30 years, doing head-up displays, infrared imaging, holography, lens design, liquid crystal displays, lasers, on and on and on, and lots of R&D and lots of creativity. It's been quite a fun job. I've been an amateur astronomer since 1963, which coincidentally was the year I was born. I own a Meade 60 millimeter 1972. Got it in 1972 when I was just 9. Got a Celestron C8 in 1988. And as an ATM, I've built an 8-inch f9, an 8-inch f5, a 12.5-inch f5. And that 12.5-inch f5 is tensegrity and GoTo. I'm currently advising and leading a group of high school students up at Ida B. Wells High School in Portland. They have an astronomy club, and they have a telescope making group within the astronomy club. It's like, wow, and you get a good science teacher, amazing things can happen. So that's been really fun, going up to the wood shop every week, and we've built a number of scopes, repaired a number of scopes, and we get out there and use them too. And in a shameless plug, I am selling these reflex sights called the Quinn sight at the lower left and the Spectre visual spectroscope at my website, and you can check that out. And I won't say any more about that. Thank you. All right, let's go to the history of silvering. Silver mirrors revolutionize astronomy, a headline appearing way back in, I don't know, 1857 maybe? No, I made this up. But the invention of the silver glass mirror is credited to the German chemist Justus von Liebig in 1835. And he came up with a chemistry, which I'll show you in a few slides, that gets silver onto glass in a rear surface mode like vanity mirrors. And of course, we all have vanity mirrors in our bathroom, and those are predominantly silver. So it's a technology that's been around a long time and continues to find its way into our homes. The first application of silver to a telescope mirror goes to Carl August von Steinheil and none other than Léon Foucault in 1857. And Foucault is the same guy who invented the Foucault pendulum, the Foucault knife edge test. And in fact, the knife edge test was first used on the very same 8-meter telescope, 0.8 meter telescope at Marseille in 1857, very same one that got the first silver coating. And he, of course, figured out silvering mirrors. And I think, boy, you know, if you leave behind 3 memorable things in the world, and they're not bad, boy, you're doing pretty good. And if 2 of them are still around after 150 years, that's pretty spectacular too. And, you know, I think about Foucault and then like Newton, you know, what did he do? The apple, some math, some optics, something like that. Yeah, he was this other brilliant guy. Spray silvering came around right around in 1930, Dr. William Peacock, and there's a company called Peacock Labs that is, I guess, still around providing some silver chemistry. But almost at the same time, vacuum deposition was developed and first applied to telescopes very soon after Dr. Peacock brought in spray silvering. So nevertheless, the spray silvering has matured and been refined throughout the rest of the 20th century into today, and it's still available. So that's what we're going to talk about. For more information on the history of silvering, go to this link here. Howard Banich put together a wonderful talk, about a half an hour, delving into more of the details of silvering. So, and just for the record, this is the Marseille telescope, an engraving of it, and that is Foucault himself. Okay, next slide. Chemistry. So, this is basically what Liebig came up with in 1835. It is primarily silver nitrate, ammonium nitrate, sodium hydroxide coming together to form silver ammonium hydroxide, or Tollens reagent, and some sodium nitrate and some water. And then you take this Tollens reagent and add to it an aldehyde, also known as dextrose in water. And that forms another reaction which frees a couple of silver atoms and creates all this other junk. Now, when you look at the warning label on the lab instructions, which you can obtain at these links, it says that things can go boom. And really, I mean, what's more to talk about on this slide? I just like looking at the mushroom cloud. There you go. But I'll tell you what, if this were an unsafe process, you would be in that mushroom cloud seeing bits and pieces of my garage. Because if there's anybody who could make this go boom, it would be me, and not on purpose. So Angel Gilding doesn't use this exact chemistry, although they achieve the same results. I'm not sure quite what they're doing. The problem material here is really the ammonium nitrate. That's bomb-making material. So you want to be real careful with that. And they say that the Tollens reagent is pretty dangerous too, but trust me, if I can use it, it's safe. And this is an available product that I guess meets certain safety standards. So anyway, so chemistry, let's move on. So after giving you a little bit of the history and the mushroom cloud, then why would we want to go old school? Well, the reason, of course, is really all about cost. And looking at the chart on the right here, I polled a number of companies. I'm just calling them suppliers 1 through 4 and not trying to keep track of who's who. And I don't really want to point any fingers anyway. But you can see what happens to the cost of an aluminum coating as a function of mirror size. And it's pretty darn nonlinear and dramatic. In fact, what I think is spectacular here is that you go to any old aluminizing supplier that has capability up to about 24 inches or so, and you're on this lower curve here. But then as soon as you want to go to a company that's capable of doing bigger, boing, it just jumps. It more than doubles. And the curves from these two different suppliers pretty much line up with each other. So there's something about having the capacity to do a very big mirror that is just cost inducing, even on smaller mirrors. And so vacuum chambers. Well, what's a vacuum chamber? It's just like what it sounds. It's a big jar, typically made out of metal these days. You pull a vacuum on it using technologies like liquid helium. You got to get things really cold to get a vacuum that's down on the order of magnitude as space. It's a very deep vacuum to get a good coating. And that costs a lot of money. It's electricity, it's time, it's a lot of time. It's helium, liquid helium, oh my gosh. So vacuum chambers, that's why the cost is so high for aluminum. As you can see, the source of supply gets very limited. I don't know of anybody but this one company that can go bigger than 30, or really 32, I guess. So if you're doing big mirrors, you're really painting yourself into a corner if you think you're going to do an aluminum coating. Shipping large mirrors is risky. If you're nervous about sending an 8-inch in the mail, imagine sending a 30-inch in the mail. You know, sometimes aluminum coatings fail early, on the order of months. It doesn't happen very often, but if it's a big mirror, it's going to be a lot more painful than if it's an 8-inch mirror, right? So, and you know, even aluminum coatings fail, and they fail more frequently if you clean them more frequently, and that is just an unfortunate fact of life. So the solution to all this then is get rid of the vacuum chamber. And how do we do that? Well, we do silver in an aqueous solution. So your mirror is getting sprayed with water and this mix of chemicals, and you don't need a vacuum. And if you're using clean materials like distilled water, you don't have to worry about doing it in a clean room even. You can do it in your messy garage like I do. So that's pretty powerful. And then when you think about, oh, gee, I can spray this stuff on, now I can do any size I want, up to the size of my wall, if I've got a mirror that I want to put on my wall. And then of course, you've got this delicate silver coating on it, and you don't want to clean it, you don't want to wipe it. So don't let it get dirty. Let it get dirty for a while, and then recoat it. And you're really, you are of course cleaning it again when you go to recoat, but boy, you come out with a spanking new coating, and it's just awesome. You could never clean an aluminum mirror to as clean as you can make a silver coating fresh. So unless you're really good and you've got a good mirror to begin with, but that's another story entirely. So you can get this stuff from angelgilding.com. It's available in kit form. It shows all the supplies. I got it on a slide coming up here. And the kit has enough material to coat a 40-inch 30 times. Now that's assuming no waste and that you've done it right. But I'll say you learn, let's say you throw away some material and it takes you 2 out of 3 or 1 out of 3 tries, you get it right. Well, that's still 10 coatings. And as I'll show you later, that's enough to last you 10 years. So this is turning into a very exciting development. And the more I get into it, the more excited I am. But I'll try to restrain myself. So is this going to make a comeback? Well, we'll see. Part of a comeback means getting out there and telling the world about it, and then people going, oh yeah, I'll try that too. So if you're at all interested, please do give it a try. All right, so this is a little bit about the kit that you can get from Angel Gilding. And this is just one. I think there's Peacock. There's maybe other ways to get at doing it yourself, but this is by far the easiest way to get into this thing. You buy the kit, it's about $400, a little under 400, and you get all of this stuff in the upper right. And in fact, there's more here than what you actually need to do a telescope mirror, because they provide materials for coating plastic. And plastic has its own special chemical that's highly toxic and needs proper disposal. And so the disposal stuff is there too. So, but you get the sprayers. That's the most important thing. You get a silver nitrate and or who knows what and a who knows what else, but it's got silver in it. All those other chemicals. And something called sensitizer, some measuring equipment, and a dispenser for distilled water and all that. And you're just ready to go when you get this kit. Follow the instructions, and then here's what you do. You prep your chemicals, you clean your glass. And when I say clean, I mean clean. And here's poor Howard with his 28-inch mirror and 3 little tiny cotton balls that he's just so diligently working that giant mirror with. We're going to talk about that later. But boy, yeah, he knows how to do a good job. That guy is one patient guy and determined guy. That's not me. So I had to go play with it. So then you clean it, you sensitize it with a tin chloride kind of a compound. And what it does is the tin sticks to the glass in like a molecular monolayer. And that gives the silver something a little easier to grab onto and forms a better bond. Rinse that stuff real good, spray your silver, rinse again, apply something called Midas Tarnish Shield, also known as Angel Guard, because now Angel Gilding is supplying it too. And then rinse it, let it dry, and you got a mirror. And instead of waiting 2 weeks and biting your nails the whole time as to whether your mirror is going to break, you've done this thing in 2 hours if you're well practiced, maybe even under an hour if you're well practiced. So there you go. You get lots of distilled water. You got to provide gallons and gallons of distilled water. And that's different than spring water. That's different than drinking water. It's even different than deionized water. But luckily, it's available in the grocery store. So usually, not always, but usually it's there in the grocery store. So let's move on. But what about tarnish? In case you're not familiar with what tarnish looks like on a set of spoons, there you go. Most of us probably have real world experience with that, but you never know these days. So you go look up on Wikipedia something about silvering a telescope mirror, and this is what you find very quickly. That silver would sure make a great telescope mirror, but gosh darn it, tarnishes so quickly that it'll just never work. Paraphrasing here, right? But the arts and crafts industry comes to our rescue again, and this Midas Tarnish Shield is provided by Rio Grande at this link here. And they've got some proprietary goop that that basically puts down a molecular layer of some kind on the silver and prevents things like hydrogen sulfide and other sulfides from ever getting to the silver. So, sounded like snake oil to me. And I thought, does it work? Let's find out. So here we go. What I wanted to do was an accelerated life test. I wanted to be able to very quickly determine if this Midas Tarnish Shield was gonna give me real world life that was practical And so could I devise an experiment that would let me take some results and then extrapolate out to a long period of time? And this is what I did. We know that silver tarnishes rapidly in the presence of hydrogen sulfide and moisture. So let's go ahead and get some hydrogen sulfide and water and put them together. And what I was provided with, this was Jerry Mertz just mailed me some of his sodium sulfide and said, here, stick this in some water and along with some salts, and you will end up with hydrogen sulfide in solution. And this thing will turn your silver black in an instant. And so I said, great, let's do that. I'll put some of the Midas tarnish shield on part of a slide coated with silver and leaving some of the silver bare. Dunk the whole thing in the tarnishing solution and measure its reflectivity periodically using something called the PMRT. And I'll go into that in 3 slides. Rinse and air dry at each interval and plot the results. And here's a photo of what that looks like, or a series of photos, along with a cartoon of the preparation. So you got this slide coated in silver. It's a microscope slide. And I put 2 marks on it at the depth of the Midas solution. And I put the slide in up to that mark. And then I took it out, let it dry, rinsed it, let it dry. And then I put it back into this sodium sulfide and salt solution, but upside down. So now I've got unprotected silver here and protected silver from the line all the way on up. So there's really kind of 3 zones of test: unprotected silver in solution, protected silver in solution, and protected silver in an atmosphere that has a lot of hydrogen sulfide in it. If you remember from your high school chemistry class, hydrogen sulfide smells nasty, and it's what's in rotten eggs and a few other biological processes, which I won't mention. But you put your nose near this thing, and yeah, you know it. So what I did then, you can see in the photo down below. Then this is the slide with its bare zone, and it's been exposed to the solution. And the protected zone still looks good. And this block right here is just a block of Teflon, which for me is a nice, convenient white reference. It doesn't have to be Teflon. You could use a sheet of paper, a paint chip, anything that's reasonably white. Over on the right, then you can see the results after each interval. So fresh coating, and then 1 minute of exposure. And right away, you can see, by golly, the unprotected silver is already turning dark, and objectionably so too. So this is a powerful solution. 10 minutes and it's hosed. 20 minutes and on, and it just gets black by 2 hours, right? While the protected side is just trucking along, and it's not until about an hour that you really start visually seeing some nastiness going on here. So what does that mean? Well, this is where then I can take measurements and start extrapolating. But before I do, let's look at the final state. This is 2 hours and 4 hours, and you can see just how beat up this protected silver is after 2 hours in the solution. So we know that the Midas is doing something really good, but it's not perfect. Okay, fair enough. Oddly enough, after 4 hours, the black part started to become less black. And I think that was just more tarnish building up and becoming an interference film of some kind. And you kind of has that rainbowy look when you tilt it around. So I thought that was interesting. Okay. Now, and there's one other thing I wanted to do. When I rehearsed this in front of my wife, she said, these don't look like pieces of silver. I can't tell what they are. And just in case anybody is as confused about these photos as my wife was, maybe that gives you a little bit better context. This is a different microscope slide and a different set of experiments, but you can see that, yeah, this is actually silver and not paint, if that helps. So I just promised I would do that. Okay, let's move on. PMRT, or photographically measured reflectivity of telescopes. This is a measurement that I had to come up with in order to have a successful test. As an optical engineer, I've got this wonderful optics lab, but it's all the way down in Wilsonville, and I'm not really supposed to do this kind of thing. And they would freak if I brought in hydrogen sulfide. Oh my God. So that wasn't going to work. I had to come up with a test on my own. And the details are in this link here. What I was able to do was measure silver using some calibrated equipment in the lab at work after hours. And that was pretty easy. I used a spectroradiometer. I used 3 wavelengths of laser light, red, green, and blue. And I overlaid those results with the reference spectrum that I got. I forget where the reference is in the link. I forget where I got it from. But that's this green curve here. And then the PMRT results are kind of reddish, green, and kind of bluish. And these 3 colors correspond to the color channels in the digital camera that I used. So it gives me a sense of how the mirror behaves, not just in overall reflectivity, but in red, green, and blue. And it's important because when silver tarnishes, it tarnishes faster in the blue than it does in the red. So you'll see that the key characteristic of tarnish is that silver turns yellow. And when something turns yellow, that means there's not so much blue in it anymore. And therefore, we really want to watch what the blue is doing. Okay, so that is the photographically measured reflectivity of telescopes, or the poor man's reflectivity test, which is so much easier to say. All right, now, these are the results. The bare silver decays quickly, the protected silver decays slowly. And you can see that very easily right here. The bare silver's in blue, the protected silver's in orange, and I've got reflectivity starting up here at 95%. And what I did was I took measurements all the way down to 40% for the bare silver, and then I just stopped because that interference film effect started to show up, and it was just getting noisy. But I was able to continue the protected silver measurements out all the way to the what is that, 2 hour or 4 hour? That's a 4 hour point. And yeah, out here, 4 hour point. And that was great because that's about where the 80% reflectivity happened. And just as a wag, I said, well, aluminum, bare aluminum is 88% when it's fresh. So let's let our silver decay to something a little less than that. So I picked 80. It just seemed like, well, okay, a reasonable number. If my aluminum decayed to that much, I'd probably be ready to recoat it too. So that's why 80%. And so you can see that, well, it takes a lot longer when it's protected to get to the 80% point. So can I predict from this data how long I can use a silver mirror before recoating? And just as importantly, what's the long-term cost? So before I get into that, let's look at the actual numbers. So the PMRT gives me red reflectivity of 99% for this particular coating. Usually that number is more like 97, 98, sometimes it's as high as 99. Green, that's a nice typical number. And blue, as you can see, for silver is lower than the other two. And that's a characteristic of silver. It just doesn't have as high of a blue reflectivity as the other colors. Still as good or better than aluminum, depending on what your enhancement looks like. And then I said, okay, I'm going to extrapolate out to the ending reflectivity of 80%. Actually, I've got measurements out at 80%. And I find that it takes the protected silver 30 times longer to reach the 80% point than the unprotected silver. So that's a 30x life increase. And if I say that my unprotected silver can last a month, which I don't know, I think I've heard that somewhere, at a month is about all you're going to get out of silver. Then that tells me I could go 30 months or 2.5 years on a silver mirror, which is really saying something. But really, can I really do that? Well, the only way to find out was, instead of doing an enhanced or accelerated life test, you got to do a real world life test, and that takes time. So here we go. We got a real world life test on my own 12.5-inch mirror. This is where it currently is. I've got over a year of good times with it. The blue bars show how the coating looked when it started, in red, in green, and in blue, and where it is today, 15 months later. And you can see that the blue channel has started to drop, but the red and the green are hanging in there quite well. So I'd say, yeah, this mirror has started to tarnish. I'm not sure that I would recoat it just based on these numbers, though. I might actually wait till it gets down to 80%. However, there's something else going on. So let's look over here. First of all, this is a quick photo of what a PMRT image looks like. Again, my Teflon block sitting on the mirror, and you can see a reflection of the Teflon block in the mirror. And what the PMRT does is it simply ratios the reflected image to the straight shot image. And if you do it correctly with a raw, you take your image in raw mode and then convert it to TIFF, and you can measure it in any number of software tools that are able to read TIFF images, especially helpful if you're doing it in 16-bit mode. And don't overexpose your image. You'll notice this image looks a little dull, and it's because you do not want any fully exposed pixels at all, or you will get numbers that are over 100%. And then you're like, oh, I did something wrong. Oh yeah, exposure. Okay, so that's the PMRT in a nutshell. But you can see what the mirror looks like when it was fresh. I call this dark field. What I did was I put my camera up to the focuser, having the telescope pointing straight up, and I put a sheet of black plastic over the front aperture of the scope, and you can kind of see the wrinkles in the black tarp there. And you can also see some very faint stains, kind of here and kind of here, a couple of dots right here. And it's not a perfect coating. I could have done better, but I was like, that's good enough. I'm going to use this mirror, so I did. 15 months later, you can see these stains are a little more exaggerated, but there's a lot of other things that are going on, and it's the accumulation of dust and dirt and whatnot, especially in the presence of humidity. This stuff is not cleanable. If you try to clean it, you'll just remove the silver where the stains are. So you just let it get dirty, and then at some point you say, that's enough. And I'm there. I'm ready to recoat this mirror. So that'll be happening fairly shortly. There you go. Unfortunately, I don't have a bright field of this mirror in its pristine state, but it's actually kind of boring because you don't see any of this stuff. It's just a nice clean mirror. Okay. Now, several other examples. So we got Howard Banish with his 28-inch. He coated his just before I did my first one in 2019. He went 11 months with it the first time and said, too much tarnish and too much spots after almost a year. He then did it again. And after 2 years, so today, basically this summer, he achieved a 2-year life out of his mirror. He said, too much tarnish, too many spots, and the blue channel was down to 78%. So it went under 80. He was done with it for sure, but that mirror was still good enough to take his last set of important observations of the Veil Nebula so that he could sketch the thing and publish it in Sky and Telescope. So, if there's ever a litmus test for a coating, boy, or maybe he's just a dang good observer. Yeah, both are true. Okay. Tom Otvos, a guy in Canada, is a 14-inch. He went a year and reported tarnish and spots in a blue channel of 83%. My own mirror in 2020, I had gone 11 months. I had spots. I didn't even bother doing a PMRT because I had stored my mirror in, I basically put a wet cover on my mirror. I didn't have a choice. Long story, but I had a wet cover. Don't do that. I recoated it. I only got 6 months out of it, because I actually changed my cover design and it didn't keep the air out. So it tarnished real fast. I then fixed my cover, and today I've gone 15 months. I've got spots and stains and a blue channel of 90%, and I'm rejecting it for the spots in the dirt. My son has an 8-inch scope that has gone 3 years, and I just used it last in September, along with Jerry and some of the other people that are on this call. It performed like an 8-inch should, and it was just fine. It has some spots on it. It definitely is tarnished and ready to recoat, but it wasn't unusable, that's for sure. It was what I expected it to be for an 8-inch. And then this Pete Pecurar has a 24-inch that, for various reasons, including the darn pandemic, it just hasn't been used. So here's a scope, a lot like my son's, that spends most of its life in storage. 3 years out, he hasn't given me a PMRT result on it, but I've seen a photograph of it with the white card on top. I just couldn't take data from the JPEG image. And it looks almost like a fresh coating. So I wouldn't be surprised if its blue channel is still in the 90s after 3 years of storage. And so what you take away from all of this is that by golly, we can get silver out to 2.5 years like the accelerated life test predicted. And that kind of blew my mind, and it's still blowing my mind because I just figured that out like yesterday. So wow, I'm pretty impressed. Now, there's some things that you got to do. There's a thing called silver protection cloth, and you can buy it at this link on Amazon. There's various other places. Basically what they do, from what I've read, is they'll take a cotton flannel and impregnate it with silver, and that silver just grabs all the hydrogen sulfide before it ever gets to your mirror if you cover it right. So I'm told the stuff will last quite a long time, like years and years and years, if you don't wash it. Because if you wash it, you take the silver out, and then it's just a piece of cloth. So very important to store your mirrors in low humidity. Don't put a wet cover over your mirror. So I had this cover with the felt or the flannel lining the cover. And, I'm out at the Oregon Star Party, and the last night, by golly, it got cold and humid. Who thought that could happen in August at USP? But it sure did. And, I was forced that next morning to pack up the scope and drive home with it. And that meant putting the cover on it so that I just, didn't damage the darn mirror. And well, when I got home, well, you saw it just was full of those white spots like I showed you earlier after just one night. So it was a shame. So protection against accumulation of dust. Now, everybody should have a cover over the mirror anyway. What you're not going to do is clean your mirror with water or wiping. You're just going to blow the dust off with a dry blower and not your breath, because then you're going to end up spitting on it, and that's not a good thing. That Midas soak time might be important. I don't really know. I've done 5 minutes. I've done 10 minutes. I'll say this, my son's was done for 10 minutes, and I don't think that was what made the difference, but it might have. So I got to put that on there. Storing in a garage or other dry and ventilated space. Well, this is, it may be more important than the silver protection cloth. I'm not sure. It's very important. Howard, what he has done is on his 28-inch, he's incorporated dehumidifiers in the mirror box. So they're just big silica gel packs that you can refresh by plugging them into the wall and heating the water back out of them periodically. He keeps his mirror sealed up real good and tight when he's not using it, dehumidified. And now what he's done, and I should let him speak for himself here, but he's incorporated a ventilation system that cools the mirror and creates a vortex over the mirror and shoots right up out the tube, out the secondary, keeps the secondary warm and dry. And so now when he's using the scope, he's basically created an air curtain, and it's all HEPA filtered and actually pulling through the same silver protection cloth, lining the filters. And we'll see, but it's possible that if you can keep the dust off this thing, that this mirror will never see a real world environment. It'll always be in some sort of clean room, which would just be really cool. We'll see if he gets 3 years out of it. Wow. Anyway, it's going to take another 2 years and 9 months before we get that result. All right. The other thing that was interesting here was that storing some samples in living space turned out to be a very bad thing to do. You would think, oh, I'll bring it in from the garage where it's always warm and dry in the house. But this was done to a silver tea kettle and a small slide. I forget who had the silver tea kettle, but I had the small slide. And both of them Midas protected, and both of them tarnishing in a month or so, as though they weren't protected at all. It was pretty dramatic. So I believe what's going on here is that there are other things in the living environment that either we put there with our bodies or are just part of the fact that we live in these sealed up houses with HVAC if you got it, and you just build up stuff in the house. So ventilated is a much better solution than sealed up. All right. What about that other stuff? I got something else corroding my mirror that's not tarnish, and the Midas isn't able to prevent it. So what is it? What causes it? Is there something that we can also do to our mirrors? And it turns out that maybe there is, and these things are testable. So in the spirit of my accelerated life test, I tried out this material called McKee's Hydro Blue, which is sold as an automotive product for keeping your paint preserved. It does, yet again, the same idea is you've got silicon dioxide nanoparticles suspended in solution. You spray the stuff on, rinse it off immediately, and hopefully enough of that SiO2 has stuck on your mirror to give it a protective layer without affecting the optics. By the way, the Midas has been shown both in star testing, in interferometry, and other things like knife edge testing that it is so thin, it is optically invisible, even to the most sensitive instruments. So there's no fear of Midas hurting the figure of your mirror. McKee's is another story though, but I'll get into that in a second. Let me tell you what I did first. So I took this slide, it's a 4x5 piece of glass, and I covered the whole thing with silver. I then covered all of it in Midas and half of it with the McKee's Hydro Blue. And then I Sharpie markered it into 18 segments. And so in each of 9 boxes, I put in these contaminants. I got dirt, crushed ant, saline, spit pollen, pine sap, lemon juice, fingerprint, and crushed match head. And those 9 are right here, and then they're repeated right here on the McKee's side. Well, the damaged areas are the ones that I highlighted in orange. And you can see that most of the contaminants I put on this mirror had really no effect. The ones that did were the crushed ant, formic acid, I'm guessing, saline, salt water, and a crushed match head, which has all sorts of nasty stuff, including sulfur and phosphorus. Well, the McKee's was able to stand up against the crushed ant and saline, but not the match head. Okay, well, maybe that's something. The only way to really know now is to understand what those white spots are on the mirror as it ages. Are they saline and biology based? Are they ant guts? Are they formic acid? Are they salt based? And if so, then maybe McKee's will be a winner for us. But it is not easy to apply. As I was about to say earlier, if you don't rinse it off immediately after spraying it on, you get a thick layer, and then your figure is hosed, and there's no hope. So I'm not quite sure what the application technique would be for this stuff, especially on a mirror that's bigger than a 4x5 slide. So I haven't tried it yet. And if I had more time, I certainly would. I've still got my bottle. If I get any volunteers, I got a bottle for you. So, when I did do it right, though, I'll say it was invisible and undetectable in testing. So that was the good thing. If you do it right, it will be a very thin layer and optically unimportant. So there you go. And let's move on. Now, let's go back a step here. You'll notice that I'm not really talking to you about how to do spray silvering. It is a process that if you want to do it, the instructions are all laid out for you in the Angel Gilding Manual. And there's plenty of YouTube videos you can go to see people doing it, both on telescope mirrors and on other things. And there's a lot of good information out there. But some of the best information is right here on this slide, thanks to Howard Banish. And it's this: get your mirror clean. Don't skip on the cleaning. Don't be tempted to try to shortcut the process. Do the proven process, which is calcium carbonate, also known as chalk. And you rub it with the calcium carbonate. That's what you saw the photos of. Rinse it, use the Angel Gilding soap, rinse it again, and then repeat. This is a multi-hour process on a 30-inch mirror, especially if you're using tiny little cotton balls. I'm an impatient person, and I just said to myself, I got to find a better way. So I said, what about this calcium carbonate? Well, there's a guy that is in our world here, used to work for a famous optical company called Tinsley Labs, and his name is Robert Schalk, Schalck. And I don't know if it's a coincidence that calcium carbonate and Robert Schalk both sound like chalk to me. But he used a lot of this stuff at Tinsley Labs to clean optics in preparation for spray silvering, which he and his company really perfected the process for spray silvering. And they would use it all the time, especially for mirrors that were still in process or for customer demos before they were ready to commit the optic to an expensive multi-layer dielectric. We're talking about space telescopes, professional astronomy telescopes, other things that are so astronomically expensive that I can't even imagine. And, there's nothing like putting down a layer of sacrificial silver to make sure you got your optics right in a real world test before you go to put something down on that is going to be expensive and durable, so that it's so hard to get off, you got to end up refiguring the mirror. You know what I mean? So, so what happened to the other steps? Well, this is what I've tried, and this is how I did it. First of all, you get the calcium carbonate. It's called precipitated calcium carbonate, which means that you're dealing with uniform particle sizes, and it's pure. There's a link here. It's mindymaterials.com. It's actually available all over the internet. I just happen to get mine here. You make a paste with your distilled water and you start scrubbing. But this is where I go different. Instead of using a little cotton ball, I'm using my gloved hand, and it's a fresh, clean glove. I just put it on, and before it touches anything, it's into that slurry of calcium carbonate. And you rub like crazy. Now, on a 12.5-inch mirror, it takes about 2 minutes to do the surface and the sides. The sides are super important. Howard goes into great detail about sides, but basically, if you have contamination on the sides and you're doing an aqueous process, the contamination can just capillary right over to the surface of the mirror and stain your mirror. So you got to keep the edge clean. So you get the edges. You change gloves frequently. You put them on like a surgeon would, trying not to get any fingerprints on your gloves. And rinse your gloves while wearing them, and then better yet, change them. If you feel like you have to rinse them, maybe better change them. You're going to rinse your mirror in distilled water, always distilled water. If you're using the calcium carbonate process only, you're going to rinse it like crazy. And You're going to wipe it with a clean glove at the first rinse to really get the calcium carbonate off, and you're going to keep rinsing. You're going to inspect with a bright flashlight and look for any kind of haze floating around in that water. If you see it, keep rinsing. And this has worked pretty well for me. I would say though that in the interest of caution, you probably want to follow up with the cleaning solution that Angel Gilding provides, just to make sure that you've gotten the calcium carbonate off. But at that point, you're not talking about the multi-hour washing process that would be required on a big mirror like this. You're just going to wipe it down, again, with a gloved hand, and clean it like you're doing the dishes, but be a little more thorough. And then rinse it like crazy again and make sure that all of that cleaning solution is off. And then when you're done, what you'll see with a clean mirror, no matter how you've cleaned your mirror, if your mirror is clean, you'll get a thin film of water across it with no breaks across the entire aperture. And it's kind of an amazing thing to see, because if you haven't seen it before, you kind of think that you're just looking at glass. It's like this layer is so thin and conformal to the mirror, you can't tell it from the glass. And then you'll see it ripple a little bit, or it'll start to pull away from the edge or break, and then you go, oh yeah, it's not clean enough. But when you see that fully cleaned mirror with that water coating it, it's kind of a beautiful thing. You just wish that you could wave a wand and make it silver, But now you're ready to actually start applying some chemistry to it, and that's the sensitizer I mentioned earlier. So, okay, so Angel Gilding doesn't mention calcium carbonate, or even they don't mention calcium carbonate at all, much less only using calcium carbonate. They sell a cleaning solution, so why would they? All right. So small mirrors. Most of what I've talked about here is applicable to big mirrors. I'm not really a big mirror person. I'm working on a 16-inch. That'll probably be the biggest thing I ever do. And we kind of saw the cost chart earlier that indicated somewhere between 15 to 20 inches, it's a break even on cost. But I think it's a good thing for small mirrors too. And $400 investment, and the chemicals last you a while, and you can replenish the chemicals for $100, and you're on your way. So I like spray silver. I like the DIY aspect. But small mirrors are a challenge because they're small, you have to get those chemicals to mix uniformly over this small area. And the tendency is to want to put your nozzles closer to the mirror so you don't have a lot of overspray. And after doing this a couple of times, I started to realize that it seems to work best for me when I actually do bring the mirrors too close, which is going to cause the coating to burn, but then I dilute the silver and reducer chemistry, the two spray chemistries, dilute it by 2x, especially if the weather is warm, and especially if you're getting close to your mirror like I'm doing. And then you're going to sweep that nozzle around really fast, like twice per second. So you're kind of going spray, spray, spray like that. If you can see my mouse moving at about that frequency, pretty fast. And so those chemicals are able to mix more uniformly just by the technique of application that way. So you keep the chemistry going slow. You move rapidly in circles. That seems to be helpful for small mirrors. You're going to spray for a couple of seconds and wait. And this doesn't matter how big the mirror is now. The silver continues to develop even after you stop spraying. It'll go for at least a few more seconds. And then you want to have a bright background behind your mirror in your coating jig. So if you can set up a bright light behind your mirror, that's super helpful because you can watch that coating darken. And in this photo here, you see my McKee's test held up to actually a cloudy sky, and you can see it's not opaque. It lets some blue light through, which makes sense because that's the light that's not reflected. And you want it to go to a nice uniform dark blue. And when you get there, then you're done. You're not going to be able to get it to go any darker than that without causing stains. So, and it's fine to hit it in small steps. So go light, hit it again with the spray. If it's not dark enough, you can rinse it in distilled and still respray. Don't let your mirror get dry. Just keep it wet. Go at it slowly, go in steps, and develop a nice uniform coating. Better than that even. This was even harder because it was such a small slide. And don't overdo it. Just stop before it gets hazy. If it does get hazy, well, then you strip it and try again. And I guarantee you will do that your first couple of tries, and then you'll go, okay, now I got it down. So apply the Midas, do a PMRT, report your results for me if you do this. I'm collecting data, and I don't have a whole lot of data, but it's starting to be pretty interesting with the data I've got. So, all right, that is the end. And I did throw a bright field picture here at the very end. This was a much earlier coating. This bright field shows some white spots that happened after that humid storage event. So there you go. We want to prevent those things from happening. All right, I'll take questions.
I don't have any in chat, so if people just want to unmute and go for it, have a field day.
Well, it looked to me like, Rob, you got a lot of data. That was great. You've got actual data, and then you've got fitted data and extrapolation data. I mean, this is awesome. So I was interested in your observation about the seemingly accelerated, tarnishing inside the house. And I'm wondering that, atmospheric hydrogen sulfide is going to be your main tarnishing agent. And what are the sources of that? I mean, you've got smog, biological sources, and eggs. I don't know if you don't store it in the kitchen. But is it predominantly H2S that's out there ruining your silver? And, running the crop?
I wouldn't be so bold as to say that it's H2S, but it's for sure sulfur-bearing compounds, and maybe it's sulfur-bearing compounds in general. I don't know. I'm not a chemist. That's what's causing the tarnish. I think there's a lot of literature on that, but this other stuff, like the white spots, that's some other chemistry. I don't know what it is. So, but sulfur-bearing compounds, whether it's smog is a sulfur-bearing compound, right?
Yeah. That's where.
Yeah.
That's why I was asking about hydrogen sulfide. It's one of the constituents, but I wonder if
sulfur, like sulfuric acid. Well, so acid rain, right, is sulfuric acid.
Yeah.
But it's not sulfuric acid until whatever that precursor is gets in the water. And is that sulfur? It's some sulfate or sulfide. I can't remember.
There's some atmospheric chemistry there, but maybe if you dude up some night, you had some nucleation or that stuff concentrates as the droplets get smaller.
You bet. So there's nothing worse than hydrogen sulfide and humidity. Those two together are going to tarnish your mirror fast.
Okay.
And whether or not the humidity condenses or not, really, it's just the humidity. So you got to watch out for that. Keep it dry. You're still going to take your scope out, and you're going to use your scope in the winter in Oregon, and it's going to be humid, and it's going to get touched by things you don't want to get touched by. But that's part of the joy. Right? I mean, it's going to decay, and so is aluminum. And if I go back to I don't want to over answer your question here, but
no, this is great. They're field instruments.
This must be Dan I'm talking to, right?
Yeah, it is. Hi, Rob.
Okay, hi. You look at this chart here, and what I didn't really hit the money shot on this, but it's $400 to buy a spray silver kit. And with that $400, you can get 10 years of life out of a 40-inch mirror, right? If you can store your silver chemicals in the fridge, you probably got indefinite shelf life on them, and you can coat a lot of smaller mirrors for a long time. And an aluminum mirror, and this is really the point, an aluminum mirror is going to last 10 years, maybe 20 if you're lucky, right? For the same reasons that silver isn't going to last forever. It's going to get dirty. You're going to want to clean it. And you're really going to want to clean your aluminum because you can't afford to just recoat it every year. So when you start looking at those numbers, it's like, yeah, by golly, we're going to take our mirrors out. We're going to use them. They're going to get old. And with silver, they're going to get old fast. But, a year ain't bad. And if you're the kind of person who's really into the DIY thing like I am, it's like, hey, we got a weekend project. Let's go do it. It's an afternoon project, actually. So there's my long answer to your short question. All right.
I've got a question about cleaning the mirror.
Sure.
Your experience has been that when you try and clean it, you just basically you take off the coating. I assume you're only taking the coating off in spots that have tarnished or have been otherwise degraded.
No.
Really, the actual silver coating just comes right off?
What you do, yeah, you're actually going to use Green River to remove your silver first.
No, but I'm saying if the mirror just got dirty with Oregon Star Party red dust, and you tried to clean it, would that wash the silver itself right off the mirror?
You can clean silver if you're very careful.
Yeah.
The point is not to have to, because silver is far more delicate than protected aluminum. And so you get Oregon dust on it. Well, our friend Dan Gray brings along an electric leaf blower just for that purpose.
Right.
And so blow the dust off until your mirror reaches a point where it makes no difference whether you've blown the dust off or not, and then your time to recoat.
Yeah, but if you have a mirror that is otherwise not damaged, if it doesn't have a lot of spots and stuff on it, it's just gotten dusty, but the dust has been locked down by dew as it does.
That's the key.
When not just like hosing it off,
Well, so I have a picture. I'm going to show you what happens when you do that.
Okay.
Yeah. Now let's see. I've got to go to nothing like real world searching on my computer for. I just saw it today, and it's years old, but I think it's this one here. Yeah, there we go. So you can see the outline of the primary mirror in the secondary right here. And all these nice little black dots, that's what happens when you rinse your mirror with distilled water, when it's got stuff that's adhered to the silver, stuff that causes stains that are bigger than the dust speck to begin with. So what seems to be happening, and I don't know this for a fact, but what seems to be happening is that if dust gets on the mirror and it gets humid and it gets wet, then the dust particle itself is going to leach out chemicals into the water that's going to form some sort of solution around the dust particle, and it's just going to eat away at your silver and spread out, and it just gets worse over time. And when you go to wash it off, freckles.
Yeah.
Those are bare spots in the coating. So I don't recommend it.
So you just don't wash these things then, do you?
Right. That's the idea, is just blow them off. And I was real good about that for the first year, almost a year probably, on my current coating. And then in all the chaos of building a new deck and moving my son out, I lost my little dry bulb blower. Had a nice little photographic bulb, rubber bulb with a nozzle on it that put out a pretty good jet of air. And every time I brought my scope in, before I put the cover on, I would bulb off the dust. And that was working really good until I lost the darn bulb. And then I was like, then I forgot I had the bulb, and I just got lazy, and now it's really dirty. So
Have you tried like a really, really soft artist's camel hair brush or something to brush the dust off?
yeah, and that does seem to work. That's not that wasn't part of my kit.
Right.
But it doesn't. It only works on the loose dust, though. Once
Right.
that dust bonds on, then.
Yeah. Okay.
Yep.
I know you guys have more questions than that. This is like the biggest bunch of telescope makers I've ever seen.
Well, I've got more questions. I'm just giving somebody else a chance. But if nobody else dives in, I'll go to the next one, and that is, okay, electroplating is a good way to get a molecular layer coating on something. But I assume we don't electroplate silver on glass because glass is not conductive, right?
Right.
Okay,
Yep.
so you're sensitizing the glass with tin. How about sensitize with tin and then electroplate rather than spray? Would there be any advantage to that, or is it just a waste of time?
It's not going to be my waste of time, but that sounds like a good idea. You should go test it, Jerry.
I'm tempted to do that. I'm about to re-electroplate a bunch of old copper bottom pots that are not copper bottom anymore. So I'll have the equipment set up.
Oh my! At home. Wow. Okay. Wow. So you would get by doing that, then you would be putting on a very thick layer of silver, I'm assuming, right? Or thin still.
This is the thing. If you put on a real thick layer of silver, it's not going to be even, and it's going to screw up the figure of your mirror.
Okay.
So you'd have to do a really light layer, and I don't even know if it's possible.
Okay. Well, try it and report back. My first response would be why, and there may be an advantage to doing that compared to the process that is involved in spray silvering, but I don't know what it would be. I think that the table stakes are cleaning the mirror.
Right.
And,
yeah. I was just wondering if perhaps electroplating would give you a more even coating without spots. But I assume any impurities on the mirror would affect electroplating just as badly as it would chemical deposition.
I would think so, yeah. And all of your challenges, I think maybe electroplating, I don't know anything about it, but if it were less sensitive to the silver burn and the white and brown stains that you can get, then that would be an advantage. But I don't know. I mean, as my old boss used to say, you want to trade your headaches today with a bunch of headaches you don't even know about?
right.
Okay. But that's what R&D is for. And that's why I got into this whole silvering thing to begin with, is because I wanted to be able to get control over that part of the telescope making process. And it really comes out of the ceramic mirror stuff that I was interested in, 25 years ago, because nobody in their right mind would put a ceramic mirror into a vacuum chamber.
Right.
It turns out there are enough crazy people that we were able to get some coated.
Mark succeeded in getting one coated, and then the glaze crazed underneath the silver.
Exactly. So then I thought, and this is a whole nother talk now, but then I thought, I'll get rid of the glaze and I'll bond a thin layer of some slumped glass to my ceramic, grind and polish the glass, and then I'll get that coated. And then I realized again that what I bonded it with could come off in the coating chamber. And I said, you know what, I'll just do silver. Well, then kids come along and responsibilities change, and I put the project away. And then, 20 years later, I'm hearing Mel talk about really thin curved mirrors. And after seeing that develop, I was like, hey, Mel, I got this thing bonded to a piece of ceramic. He's like, yeah, that'll work. So I'm now making my ceramic mirror project a meniscus mirror project with silver, of course.
Okay, so talking about meniscus mirrors leads to my next question. So I'll just dive in with that.
Okay.
you've heard about what's called Mangan mirrors, right?
Yes, yes.
A Mangan mirror has the glass in front and the
Mhm.
coating on the back.
Mhm.
And, the glass is a very uniform thickness, and it's curved in just such a way that it'll act as a Schmidt corrector on the surface of the mirror. So you can make
Ah,
a spherical mirror with a Mangan surface on it and coat it on the back instead of the front.
I was with you until you said Schmidt corrector.
Well,
Yeah,
okay, effectively, it's doing sort of the same thing.
The problem is it's not. It absolutely isn't doing the same thing. I've tried this in
Okay.
optical coating, of course, and it doesn't work, by golly. What you want that corrector to do is fix the errors across the pupil. And
Okay.
where you're applying that glass is right at the, well, I guess it is at the pupil, isn't it? But it has to be, to do it the way Schmidt did it, it has to be at the center of curvature of a spherical mirror.
Right.
To do it what Schmidt is doing. Now, Celestron and Mead have come along and they've moved that corrector in to almost the focal point instead of the center of curvature of the spherical mirror. It still works, but when you move it all the way to the mirror like that, it just falls apart and you don't get the correction you're looking for. You still have to parabolize your mirror, but now you've added on top of it chromatic aberration.
Right.
From this other thing. So the deal is, though, that when I did that, I got to go back and look because I probably assumed a thicker than meniscus substrate back when I did that.
Mhm.
And now that I know that we can make accurate mirrors that have 40-to-1 thickness to edge ratio or 50-to-1, then that's worth another look. But
Right.
it's the chromatic aberration that's going to kill it because of where it's located.
Right. Okay. So where I was going with this is the
Okay.
idea Mangan mirrors are coated on the backside instead of the front
Yeah,
side.
yeah. And that'll protect the silver for a long, long time, just like
Well,
in your bathroom.
yeah, what you do is you deposit your silver on the backside, and then you just spray a coating of paint over it, and
Right.
and that'll protect it forevermore. So the question kind of becomes on a really large mirror if it would make sense to parabolize it on the backside and coat the backside and coat it in silver and only have to coat it once.
Right. Well, what you got to do is create an effective parabola using two surfaces instead of one.
Right.
And then you got to deal with the chromatic aberration. So if that holds up, if you can do both of those things, then there's one more challenge that you have to deal with. And that is, what about the reflection from the front surface of the glass? And at 4%, that might not be too objectionable for faint fuzzies, but planets, moon, stars, double stars, all of that, you're going to get one heck of a halo.
Yeah, you're right.
You got to watch out for that one. So now it's like, well, where's that aqueous anti-reflection coating that I want?
So it sounds like what I've done is I've invented a way to cut down on the number of times you need to silver a mirror, when the reason for silvering in the first place is that it's a heck of a lot easier than luminizing.
Exactly. In fact,
so I'm solving a problem that doesn't really exist.
when you think about what problem it is you're trying to solve, then it really changes things. And cleaning an aluminum mirror is a sketchy process right out of the chute. If you know what you're doing, you can do a good job. Most people that have telescopes don't have the resources to properly clean a telescope mirror, especially if they want to get 20 years of life out of it, right?
Yeah.
And I mean, you can go look online, you go get the equipment you need and all that stuff and develop it and learn how to do it. And then you're still going to be nervous about it. And then you're going to make a mistake one day and you're going to scratch your mirror or whatever it is. It's just going to wear out faster if you're cleaning it, no matter how good you are at it. So then you trade that set of problems against, well, if I'm going to clean it once a year, why don't I go whole hog and recoat it? Because when you get into the level of really properly cleaning a mirror, let's get Bob Chalk on the line. We'd probably find out that cleaning an aluminum mirror and cleaning a substrate for silver coating are not a whole lot different still silver might be harder, but in the end, what you have with silver is practically a perfect coating. And where the aluminum is in some way compromised, especially if you make a mistake, and there's no fixing that mistake. So,
I don't know if you guys saw in chat what Mel wrote. See,
oh,
solid glass cast mirrors. The secondary is curved into the front of the glass plug.
yes.
One of these mirrors is going into space, courtesy Portland State University or a Portland high school.
Portland State Engineering Department. And it may not be a surprise to some of you that I'm plugged into that whole project. A few years ago, they came to the Rose City astronomers. Their faculty advisor gave a talk about their little two unit satellite they're going to launch. And when he got to the camera part of it, he said, you know, we can't figure out how to get a camera into the scope that's small enough to actually image the ground at the resolution we want. And he thought maybe somebody from the Rose City astronomers could help. So I said, okay. And after meeting with him a couple of times and understanding the problem, I said, well, I think what I said was that you guys really need a micro Schmidt-Cassegrain that's, you know, like this big. If you could only find one somewhere, they don't exist. And then I parted ways and I haven't seen them. And then somebody posts that very same video link. There's a wonderful video out there on YouTube of this guy in the Netherlands hand polishing these tiny little fused silica plugs that just he's got 3 surfaces to polish on them, and then by gosh, it's an entire Schmidt-Cassegrain telescope and he's done. And it turns out that Portland State found out about him and got him to make one for them. And then this video comes out, and on Friday this week, I'm taking my high school group to go visit, and we're going to see the thing in real life. So I'm super excited. Yeah. They launch their version 0, I think they're calling it, in January, and they're shipping it off to the launch facility in early December. So we have a short window where we can actually see it, and they're going to take pictures with it all the time. So okay, show me. That'll be cool.
So is there any way a guest can join you for that tour? And I don't ask that just for myself. I ask that for all the readers of Sky and Telescope, because I'm writing an article about Rick's telescope.
Okay.
And I would love to actually
Jerry, let me get you the contact information of the advisor. I'll do that offline.
Yeah,
and
please do.
You can call him directly, and he's super friendly and excited and motivated, and y'all can work something out with Sky and Tel, and that would be freaking awesome.
Yeah, I'm writing about this scope, so if I can actually see the satellite it's going into and get some pictures of that, that would be sweet.
Got it. Yeah. And if it's just you, it'd be fine, or just me and you, it'd be just fine. The high school group is another matter entirely. So
yeah, okay. We'll set up a different time then.
Yeah. Okay.
Well, dang it, I thought we were all doing a field trip.
Yeah. It's not a very big room. Yeah.
And I know we've all put on a few pandemic pounds.
Oh, well, there's that.
I got a quick question, Bob. What's the difference in reflectivity of a brand newly coated silver mirror versus a high quality aluminum coated mirror?
I've got an answer to that one for sure. So if you're doing enhanced aluminum actually is pretty competitive with silver. And I'm going to go back to my talk and see if I actually put that in there. I thought I probably just glazed right over it. Oh no, I just used the silver chart. I will have to, let me just say this. Enhanced aluminum in the red through green looks a lot like silver, hovering around 95%. But then enhanced aluminum takes a little bit of a dip in the blue and then comes right back up again and goes flat out into the UV and then falls off. And then It may have another dip in the deep red or something like that. So it's got its own funny little spectrum. But the two, silver and enhanced aluminum, in the visual band, I emphasize the visual band, are very similar. And when we're using our eyes at night, we're pretty much using a narrow band centered around 500, like 450 to 550-ish, kind of this nighttime scotopic. And it's very competitive with the enhanced aluminum. Now, I've heard tales, and I'll just keep them as tales for now, that that silver, just that a fresh silver coating looks even better than a brand new enhanced aluminum coating. I don't know if I buy it. It may be true, but I think a lot of it is subjective, and there may be just a lot of excitement about the fact that, by golly, I've got a brand new mirror and it looks great. So I know for myself, when I recoated my old enhanced aluminum mirror that was so old, I was seeing holes through it and it really was dirty and I couldn't clean it. And then when I recoated it with silver, it was dramatically better. But that was old aluminum to new silver. So
Right. So from your graph there, it looks like they're fairly similar in reflectivity.
yeah, I'm not showing you enhanced aluminum, but if enhanced aluminum were on here, like I said, it would be right up around 95% through the UV and blue with a little dip, and then right back to 95% again through the blues and greens. And then maybe it starts to tail off in the red, depending on the coating design. So
Cool,
it's
thank you.
pretty comparative. Yeah.
That's awesome.
Yes.
I got an enhanced coating one time that didn't actually work very well. It was really, really blue. It looked hazy blue.
Oh,
And I'm wondering,
Yeah.
did they just overcoat too much of the overcoating and give me an interference pattern, or what's going on there?
I wouldn't know without seeing it, obviously, but
It's been stripped and recoated, so it's gone.
yeah, okay. There are a lot of things that can go wrong with coatings, and I'm not a coating expert by a long shot, but I've certainly been around them for a long time. Coatings can be hazy, and that can be a function of a lot of things: the purity of the chemistry going down, the purity of the vacuum that they used when they coated it. It could be whether it's a densified coating or not, or just a whole host of things can the variables get into these coatings, and you really have to have good process control to produce a good coating, especially if it's a multi-layer enhancement on top of aluminum. It's the multi-layer stuff, tight tolerances on thicknesses, refractive indices, uniformity, purity, density, on and on and on. And yeah, it's a whole other field. So
Okay, thanks.
I got a question for you, Rob.
hey, Howard.
Hey, great presentation, by the way. I just want to ask what you think of possibility or probability of finding an easy to apply overcoat for silver that will protect against atmospheric contaminants.
Well, I'm cautiously optimistic. I thought that what I did with the Midas showed that, by golly, at least there's something it will do that Midas doesn't, and that's the bug juice and the sodium chloride, the salt. Now, it needs a real world experiment, right, where we let our mirror get dirty and dusty and see what happens. That may be the solution. If it's not, I suspect that it won't be long before somebody else comes out with some other product that does something like that. The whole field of nano crystals and nanoparticles and all that is exploding, especially in the semiconductor world, and microelectronics and whatnot. But the things that come out of that are things like this. It's like, hey, I've got this solution of stuff. I wonder what else I can do with it, So you get McKees. So that may be a thing. I'm cautiously optimistic. I'm actually cautiously optimistic about McKee's itself. It's just a matter of how do we get it on the mirror and not screw it up. Number one, and then number two, when we put it into a real world test, does it actually do something like it says it does?
Okay.
Yeah.
All right. That's interesting, and it's something we can talk about offline at some point. But
Yeah.
aside from that, like everything you've just explained, recoding with silver every so often is not that much more of an effort than cleaning an aluminum mirror. And you come out with such a beautiful, brand new coating whenever you do it, that, it's, once you get it down, it's fun to do. And
Awesome.
so it's, the longer we make these last, the less fun we're going to have.
Howard, when you first did this, first of all, that's an awesome recommendation. And second of all, understand that Howard got into this project going, that's a 100-pound mirror or something like that I got to lift out of its telescope in order to recode it. He's like, if this doesn't last me, I don't forget what you said, at least a year or two, then I'm not interested because it's a lot of work. And now you're telling me how much fun you're having. That's awesome.
Well, now I have the process down.
You do, yes. But it is a challenge on a heavy mirror because you're faced with either lifting it out of the telescope, and you have go to Howard's link. He'll show you what they did on, was it the 60-inch at Mount Wilson? Yeah,
Mount
it's
Wilson,
on this.
Yeah.
It's on this on railroad tracks on this giant iron fixture to get it out of the telescope, right?
Yeah.
And coat it. But the bigger the mirror, the harder it is to manipulate. So at some point, you either go thin meniscus so you can manage the mirror, or you build into your telescope the ability to do an aqueous spray and not ruin your telescope. That could be cool. You talked about doing that, Howard. I'm not making this up.
No. Well, you look at those images of the Marseille 0.8 meter telescope that Foucault made, and they obviously had the bottom end of the mirror cell made so when the telescope was pointing straight up, that cell would pop right off, and you could get to the mirror and resilver it.
Yeah,
that was part of the design. So, yeah, it's not a new idea, but it's something that amateur telescope makers haven't had to contend with because we've all aluminized our mirrors and just now getting back to the whole silvering thing.
right. It's pretty remarkable, to sit here as long of a history as we've had with aluminizing, and it's just ingrained. That's how you make a mirror. And then to look back so far and go, my God, they've solved all these problems long ago, except for the durability. And so we still have, I think, a lot to learn just digging out what Foucault and company did up through 1930. But then we're in this wonderful place where modern technology can do some things that nobody dreamed of 150 years ago. And that's really exciting. So, and design your telescope. If you design your telescope for the way, for the materials that you're going to use, including the coating, oh my gosh, I got to think about the coating now. Yeah, you do. Because if you think about the design of your scope from the get-go and how you're going to coat that mirror, that will make all the difference, especially on a big telescope, but even on a 12-inch. I used to have my 12-inch mirror bonded to the iron, the steel structure in the back, the whiffletree. And I didn't need to use a strap, it just was bonded on the 9-point flotation cell. But then I had to take the whole telescope apart just to get the mirror out, the whole cell. And then coating it, I rusted the iron and it was just awful. So then I said, okay, I'm debonding the mirror, and now I can just lift the mirror back out, and I've got to have another retention system in there, and that works. But it was like, oh, if I'd have thought about that at the get-go, I'd have a different solution for how my mirror is mounted today. And I'd be happier with how it stays collimated, I'll bet you. So all these things are important.
I love the video for what's his name? The guy who does the Obsession telescope. He has a video on how to clean a mirror in place in the Obsession telescope. And the first step is to drill a hole in the bottom of the box so that all the water can run out. I can't imagine anybody who spent $3,000 on an Obsession telescope just going after it with a hand drill.
Well, he obviously listened to you, Mr. Roltion, who says, if it's not your scope until you drill a hole in it.
Well, there's that.
Thanks for the quote.
Yeah.
Then it's definitely your scope.
That's right.
I
I'm
think
going around putting holes in everything I own.
Yeah.
I would say here in Oregon, where we don't have a whole lot else to do until June or July, certainly an annual mirror silvering party where we all get together and prepare our mirrors for the summer.
Good idea.
That seems like it could become an Oregon tradition.
I'd love for that to happen. And I think we can make it happen. We just got to decide we want to do it. All in favor?
Oh, yeah, absolutely. You know what it would do is it would knock down the cost per mirror. We have one person in charge of the silvering equipment, and we all just kick in a percentage of the cost of the chemicals based on the surface area of our mirror, I suppose.
Yeah. And the number of us that show up.
Yeah. It's
Yeah.
pennies. It's just, I was going to show you a cost chart that, and then I decided it would be embarrassing if I did. So you see what I did was I made silver flat line at $400. That's the cost of the kit, right?
Right.
But if you go by the number, let's say you can get 10 coatings out of your kit. Now you're at $40 a coating. But then if you further divide by the area, these small mirrors are below $1 a coating. They're like 50 cents, some of the smaller ones. And it's just nuts. It's like, I'll do it for free. Just clean it for me, But, certainly on a bigger mirror, and if there's a lot of people that really want to do this, well, then let's chip in and buy a set of chemicals and use it for that purpose. That would be totally reasonable. I think it's like $120 for the Part A and Part B by themselves. I just bought new chemicals this year, so I should remember. I think it was 120. Yeah, let's do it, man.
Well, one other thing that I wanted to say, I think it's really cool that everybody's using all this stuff from other, crafts, hobbies, stuff like that. Like, you could try to find something that's more perfect than the coating that they make at Rio Grande, but I'll tell you what, jewelry isn't going anywhere.
Right.
So, having something that's useful to the jewelry industry, that product's going to be around forever.
Yep.
So I think that's always
Likewise with car paint, So hopefully these people who care about their expensive cars are enough of an influence to help us out too.
so that's a good it's a good product to make work, I think.
Yep.
Hey, wait, are you saying people are actually painting their cars with silver?
No. It's the McKees that I pointed out. That's a car product.
Okay, yeah.
Yeah. So yeah, you
You know
what?
It's actually illegal to paint your car reflective silver.
Oh, good.
A friend of mine tried that one time, and the cop just pulled him right over and said, "Oh no."
Nice. I've seen some car paints that really trip you out. They are putting some optics into car paint in the form of nanoparticles, and you get car paints that actually change color with viewing angle.
Right.
Yep.
And they're cool, man, on a race car. And they're not cheap, I'm sure. So you're going to want to protect that. And okay.
I have to say, those are trippy to see. They really are.
Yeah. So that nanoparticle industry, I mean, that's where I think we're getting our benefit, both for the silver both for Midas, that's got to be a nano thing too. I don't know what it is, but it's clearly got something cloudy in it. You know, it's not a clear solution. There's something in it that I don't know what it is though. Nano something.
They're not saying either.
No. I have a juggling friend who I'll attribute this one to, but he would light juggling torches on fire after dipping them into a witch's brew of 9 essential carcinogens and iron. I like it.
How's he doing?
Great. He's no kidding. He owns a house in Northeast Portland. He's got 2 grown daughters who have gone through college, and the pandemic's been hard, but he's still trucking along.
Oh, all right, good. All right.
Yeah, man.
That's not the Unipiper, is it?
No.
Oh,
No.
okay.
No. We're getting way off the subject now, but okay.
That's EAS.
Any more good questions?
I've exhausted all of mine, so it's up to you guys now. More questions.
Dan's
I
talking
have
space
one more.
vampires, so.
I have one more question, and that is,
Sure.
once you get done with the silver process, how fast or how much time do you have before you put that protective, so to speak, coating on it?
It's immediate. So you really don't even let it dry.
Okay.
I hope I put it in my notes that way, but yeah, you rinse the silver, and then what I do is I actually I rinse the silver, and then I put a duct tape dam around the mirror as best I can, even though it's wet, and then just pour the Midas into the dish of the mirror and let it fill up to the tape a little bit, and then just let it sit there in a pan so that the leaking Midas can have a place to go. And I make it a clean pan. And then when I'm all done, you know, I'll pour off the Midas and rinse the mirror. And then I take that used Midas and I just funnel it back into the original bottle. It's not, you're not using it up as you go. So
you recycle the unused Midas, and then so you're applying that while the silver's still wet, so to speak.
Soaking wet with distilled water. So the Midas is water soluble. It's an aqueous solution as well. So
right.
I think you can let your silver dry first and then Midas it. That's certainly what the jewelry industry is doing. But to me, it's like there's no point. It's just, you just do it and it's clean, and it's, you know, when it's in distilled water, it's perfectly clean.
So then you're rinsing off the Midas after you put it on. So it's a really super thin coating of it then, correct?
That's apparently what it is. It's undetectable by interferometry, Ronchi test, knife edge test, star test, you name it. We can't find it, but it by golly is there. So
and you can tell it's there after you apply it and you're rinsing, because it makes the silver hydrophobic.
Yep.
The water just jumps off the coating.
Oh,
yeah. When you do it right, then you can dry your mirror as you're rinsing it. You have your flow of water just so, and you hit all the little drops that they just beat up and fall down your mirror. And when you're done rinsing, your mirror is dry.
Wow.
Put it in your scope and take it out that night. Why not?
Very cool.
Yeah. Now, in fact, it's not really dry. There still seems to be like a bluish haze that will either disappear or greatly reduce as the mirror is chemically drying. So I think there is still some trapped moisture in the matrix of silver molecules and whatnot that's on there. But you certainly, you don't hurt anything by putting the Midas on when it's wet. And you will notice very likely that there's this blue haze, and just give it some time, typically a day in a dry environment, and it'll be much clearer, if not perfectly clear, by the time it's fully dry.
Do you wear a canister respirator when you're doing the spray portion of it?
I do not. I sometimes just wear a COVID kind of a mask. You will see that the angel gilding person is wearing something over her. No, wait, or is she not?
I don't think she
No,
is.
she's not.
No,
That's
she
right.
isn't.
She didn't have anything on her face.
Right, she's not. The reason I'm not worried about it is that I never do it indoors. I've at the closest to being indoors I've done it is at the edge of my garage with the garage door open on a rainy day. And otherwise I'm spraying when I'm actually outside. And you know, the stuff has a very ammonia odor to it, so you know when you're breathing it. And you do it right, you know you're not breathing it, and you're okay. I'm not saying don't wear a respirator. You're certainly welcome to do so and encouraged to do so. But my experience has been, it doesn't seem to be that important.
I'm just guessing there's super tiny particles that are floating off and away from the spray too.
Yeah, I wear a respirator. After the first time when I didn't, and I got a whiff of that ammonia type smell, made my eyes water. And it's like, okay, there's some bad stuff here. So I put on a respirator, even though I do it at the edge of my garage with the door open and a fan behind me blowing outward. But yeah, I just, one whiff of that was enough for me.
I'm surprised that you guys are doing this outside after all the care you're taking to clean the mirror, that, you know, there's going to be some kind of atmospheric particulate that's going to land on it in the process.
That is a very good point. When you put aluminum or other vacuum deposited coatings down, you're doing it in a clean room or something that resembles a clean room. This is not that. It's an aqueous solution. And there is, by golly, dust falling from the sky into your solution. But you're not giving it a chance to stick to the surface. And it's not that sensitive of a process. I'm guessing that, you know, it's not like one piece of dust falls into the solution and causes a bad reaction over the whole surface or anything like that. You won't even notice it. So yeah, outside is fine. I would say, you know, doing it on the exhaust of your table saw while somebody's cutting wood would be a bad idea. But
we won't do it in Jerry's garage then, huh?
Right. Yeah, it's not overly sensitive to airborne contamination as you're doing it. You're just not giving the contamination a chance to get to your mirror.
Well, I just recoated my 18-inch mirror, and I don't even know what the process of stripping off that aluminum oxide would be, but this is very interesting.
Well, yeah, you're not in a position to recoat for another few years, I would hope.
Right. No, I've got a good investment in this one right now, and I haven't even used it yet. So.
Oh my, yeah.
Yeah, unfortunately.
Well, you can still come to our party if we have one. Just bring a different piece of glass. And for that matter, you know, coating a test piece of glass isn't a bad idea either. And it's exactly what Howard did. Howard did on his first attempt. Was he had a nice big
practice down.
Yep, not a bad idea.
Cool.
Especially for something big, you know, it's like, God, how am I gonna work this thing? So.
What if you put it on a lazy Susan and spun it and then just held the sprayer and just kind of went from the outside to the center and then back out again? Or that.
One of the things that you want to do when you're spraying is you want the fluid to fall off of the mirror, but not too quickly and not too slowly. And so generally you set up a rig where your mirror's at an angle.
Okay.
It could be a shallow angle or a steep angle. It doesn't seem to be too sensitive. I've even done it where I said, you know what, I've got such a small optic, I'm gonna forget about the spray, and I'm just gonna go old school and pour the two solutions on the mirror and just swirl it around like it's, you know, like it's swirling in a dish, right? We keep it moving is the idea. And so when you say lazy Susan, I'm like, oh, wait a minute. That's kind of what I did. And maybe you spin the lazy Susan on a motor and make it go just fast enough that it can cause the fluid to leave the mirror.
Like a centrifugal force from the
A
center
little
to
bit
the
of
outside.
the force might be a good thing.
Yeah.
It's an R&D project. Somebody should go do it.
Cool.
Yeah.
You got people thinking, I don't know if that's a good thing or a bad thing.
I wouldn't do it.
Not with a 28-inch mirror. No way.
No, not with any size mirror.
Oh, really? Okay.
Oh yeah, that adds. It works fine the way we're doing it now.
You're right. You're right.
And spinning it around isn't going to make the mirror materially better.
Yeah, but there's the
Absolutely.
fun part of it, though.
But for some, if you want to do it, do it. I mean, that's the great part of this is that, and I could be wrong.
Yeah.
I'm wrong 10 times a day at least, usually. So
Yeah.
it just doesn't sound like an attractive project to me.
I'll tell you why it's an attractive project to me, and then I'll tell you why I'm not going to do it. But first, I'm going to tell you it's attractive because small mirrors are a challenge, I think. And okay, I could just go old school and pour the solution on like I did, and like we've seen the 1960 silvering video. Perfect. And so why am I not going to go do it? Well, because I can do that, I guess. But it's one of those ideas that you don't say no to. You say, maybe it's a good idea, maybe it's a great idea, because who knows what comes out of it. I don't know. But I think I'm with you, Howard, in that it's not broken. I'm not going to try to fix it, right?
Well, if someone does it and shows, hey, wait a minute, this is better because of X, Y, and Z, I'll be all over it.
Me too. Yep.
Yeah. So if I'm getting a over 97% reflective mirror, doing it the way I am, and I can make it last for a couple of years, I'm a happy boy.
Absolutely. Right.
That answered my question. You're getting 97%, Howard?
Yeah. Then every coating, it seems to come out a little differently in terms of overall reflectivity. My
Right.
second coating came out to average 97%. It's like 99% red, high 98% in green, and what was it? A high 96% in the blue.
You just average it.
97%.
Yeah.
And
If you
then
look at example, it's very similar, right?
Yeah.
Maybe a little lower in the blue, but those are typical.
Yeah, it's fairly typical. So then I combine that with my diagonal, which I have an enhanced aluminum coating on, which at 45 degrees reflects a 97%. I got a total transmission through the telescope that's off the charts.
Yeah.
Can't wait for the Oregon Star Party.
Yeah, well,
Yeah.
I don't know. I don't know if I want to wait for OSP anymore. If it comes back, I'll be there. But
Interesting. I wonder how the forest fire smoke would affect the silvering mirror.
Yeah, good question. I don't know.
That's pretty carcinogenic stuff. So,
Yeah.
and it's
Well,
very fine particulate. I'm sure it's not going to be healthy for it, huh?
If anybody's scope can weather that storm, it's Howard's. Again, keeping the mirror well sealed and covered while you're not using it is really a very important way to keep your silver to last long. Now, if you're out there at the OSP and it's so smoky that your silver's corroding, you're not observing, right?
Yeah, right.
So
Now you're packing up
otherwise-
and going home. Yeah.
yeah, exactly. So, if you smell a little smoke in the air, but it's a clear, glorious night, that's camping, man. And I'm observing,
Yeah.
right? So
You're here.
Yep. Well, I appreciate your talk tonight, Bob. Thank you so much.
You're welcome. Thank you. I think this is a fascinating topic, and I'm glad there's other people who are interested in it. And
Oh, yeah.
I also want to tell you that as time goes on, you're probably going to see a little more of me. I've got a son down in Eugene. We go there often, and I'm certainly enjoying it. So I'm quite honored to be at least a tangential part of this group. I should just join.
You should, honestly. I mean,
Yeah.
I moved away and I'm still involved with, I'm in
Mhm.
Albany. I'm not even in Eugene anymore.
Well, we're
Yeah.
grateful for you too, Amy. Thank you.
Oh,
Oh,
yeah,
thanks.
Amy, you're the heart of
Yeah,
the club
thanks.
these days. Come on.
You.
All
Yeah.
right, everyone. Again, thank you. And, I think this will be available as a video, and it definitely is
I'm
available as a
hoping.
PDF that Amy has, and you're
Yeah.
welcome to send that out. I hope the links work in the PDF. They often do. Feel free to contact me through email. You can get that from Amy as well. If you have any more questions, or you want to really get started in this thing, reach out to me, to Howard. I know Mel was listening earlier, maybe he still is. Mel knows a little bit of something about this. And we'll make this thing another Oregon thing for sure. And boy, change the world, right?
There you go. Yeah, Mel's going to know a lot more about this pretty soon.
That's right, he is. Yeah.
I'm a little nervous about the recording because I was getting some error messages earlier and I'm stressed about that. But if it works, it does. And it'll be probably by the end of the weekend. I'll have it done because I got a super busy work week this week. We got slammed on the recruiting and then for the PDF, then I do have the most recent one, and I'll put that out through all three Eugene, Corvallis, and Salem groups.io forums.
Thank you, Amy.
Thank you, Amy.
Sure.
Well, thanks, Rob. That was a great presentation.
Yep.
My only other thought on it is your cost graph. It only shows for one eyeball.
Good point.
So if you're doing your telescope correctly, then you get one mirror for free with silvering.
Practically free. Yes, you're right. It's freaking awesome.
So
Yeah.
just
Yeah.
another thing to think of. It's another great advantage of silvering. I mean, seriously, if I were gonna make I think the project of making a big binocular should be making your own mirrors too. You can buy like some 16-inch f4.5s from GSO that would probably be really nice, but if you're gonna have a really big binocular, then why not make your own mirrors, and then you can do the whole darn thing, except for the secondaries. But I guess one of us got to figure out the secondaries too.
Yeah.
Maybe I can make them on my flat laps back here. I don't know.
Yeah.
I haven't tried it.
Wow.
I still remember John Wally saying that he doesn't hate anybody quite enough to teach him how to make a secondary mirror.
Well, I loved it. Rob, if you ever want to experiment with some of those, quantum dot semiconductor nanocrystal coatings, I have a line on that.
Ooh, yeah, I bet you do.
We manufacture them, as a matter of fact, and they're the same ones that go into the TV sets, right? It's the same tech. But up converting quantum, I don't know. You need a lot of light to engage semiconductors. I think that those are more for light amplification, not so much gathering.
Yeah, Dan, I'm in this context, I'm not interested in either absorbing light generating light or fluorescing or anything like that. I'm
Just
interested
reflecting.
I'm interested in creating barriers to tarnishing compounds.
Yeah, yeah.
That's a whole different problem. But could we make a telescope mirror that functions as a gain medium?
Say that again.
So you got light coming in. Oh boy, we're off in space now. So light comes into the telescope mirror, hits the mirror, and is not only reflected, but is reflected with more energy than it came in with. That's a gain medium, right?
Up converted. Yeah, up converting
It's
dots.
not up converted. That would be frequency modulated. I'm going to change blue light to UV light.
Yeah, we based on the band gap of the quantum dot, right? Okay.
But actually, the same wavelength with more energy in it, so it's a brighter image. Oh, that's a night vision goggle.
Yeah.
Of sorts.
Okay.
Well, maybe we do up convert. Maybe we're taking near infrared and up converting into the visible, but with gain, so that it's a night vision goggle. Oh, that would change. That would change the world. You know, a single surface amplifier like that. It doesn't exist. Doesn't exist today, not to my knowledge. But
this is kind of like what some of the new Astro cameras do, isn't it? They amplify the light they're seeing.
Yeah, that's well.
not
There's a
without an
few ways that-
intensifier tube.
Yeah,
No.
that's like electron multiplying CCDs or avalanche photodiodes and scientific CMOSs and all those. Those are just increasingly, juiced up, modalities for amplifying, but they there's no reflection, no reflection that happens there. Rob's talking about both, like somehow reflecting it back at you with more sauce.
Right.
Yeah,
Well,
yeah.
I like the idea.
I love it too. I mean, that'd be.
Sign me up.
I wouldn't be
I would
surprised.
plug it in. I would
I
have
wouldn't be
Howard.
surprised if before I die, somebody's actually building something with that idea in mind. It may not be a
Especially-
telescope mirror, but it would be some high-tech thing that in some way affects our lives in a way we can't even imagine. I don't know. There's lots of nanoparticle-based detectors and other things in optics that are pretty cool. That it's all the physics is controlled by the particle size. Why not a gain medium? That'd be, man.
Well, so back to silver in one final thought though, just in a practical sense. So what you said is you're ultimately looking for something that a sealant or some conformal coating that would do it. And another, did you kind of rule out silination? Because there's a lot of silination products that again we use in the sciences to make surfaces inert.
Right.
That's
silane based stuff.
Yeah,
Silanate?
it's silent, and it's just a generic term. I mean, it's kind of a harsh treatment, but there are a few silination products out there that will put. I don't know. I don't know if it'd be protective or not.
Dan, we should talk offline about that for sure. I'll tell you this, and this is for everybody. I did this experiment, and I was super happy to get a positive result out of it. I'm not in a position to repeat it at the moment. I wish I was. I would love to go work this McKee's stuff, but this is a call for help to the community. Like, if we want to advance this technology, it can't be me doing it. It's got to be a group effort, really. And there's a lot of really good brains out there, and I'm looking right at you, Dan. And let's put our minds and our bodies together, pool our energies to get some furthering of this technology. Because, like I said, I'm cautiously optimistic, but I think if it's a concerted effort by some smart people, then I become optimistically optimistic. I think we could solve it. So let's see what we can do. Crickets.
Yeah. Right. No. Right on. No, I'm all in. If especially someone to start a group and do a coating. I'm like Randy. I just got my mirror coated, so I'm not going to be looking for coating for a couple of years. But I've got more than one telescope too.
Yeah, you
That's
can always
right.
grind in another mirror, Dan.
That's
Yep.
for sure. And you don't even have to have a telescope to want to
Well,
do this.
actually, no, just a minute. I actually have I have about 60 telescopes at my disposal that I can just start reeling them in from the lending library,
There
being
you
the
go.
librarian and all, and just trying it out. And just have test subject after test subject.
Yeah. You know, I didn't.
I'd help, but we already know that I was not brought into this group for my extreme knowledge of astronomy.
Well, it doesn't matter. We need people to run these experiments, and I'm not joking. If you can follow a process, you can help. You know, anybody can help move this technology along. They just have to have the love of science and the interest in getting some results out, and you know, stuff can happen. People with time on their hands and the interest, we need them.
Yeah, time's another thing I don't have.
I'm not talking to you in particular.
Okay, good.
The whole group, you know, everybody. It's not that hard. It certainly wasn't that hard to do the life test. I think the PMRT took a lot of insight to come up with that, and I feel lucky that it worked at all. But the life test was just a matter of, you know, sitting down and doing it. And it's, you know, you got to coat the silver and then put the midas on and then do this life test and and then write a report on it and the whole thing. And it would just go so much quicker with, or maybe it would go quicker. At least it would feel easier if I had help.
Well, I think if you got a bunch of people together doing it at the same time,
Yep.
then not only would it be more fun, but you'd also be able to, oh, that worked for him and better than what I was doing, kind of thing.
Exactly. You get a lot more, you can test out a lot more variables, and you can see how repeatable you are across different users and all these things that I just don't have time to go explore.
Isn't it Jerry or Robert or someone that has a line on like this endless supply of cheap blanks? Couldn't we just get like a dozen 4-inch mirrors and just subject them all to a series of systematic, treatment? Right?
The substrate can be just any glass. I'd go out to Home Depot and get window glass and dice it up into samples and coat those.
Yeah.
The flats are just fine for this kind of durability testing.
Yeah.
So that's cheap. Yeah.
All right. Very fun. Cool stuff, Rob. Thank you.
Thank you. I'm just going to sit here until you turn off the meeting. So
I was going to,
talking, man.
I'll stop recording.